Ladies and gentlemen, hello. It's a great honor to attend this meeting. Now, let me elaborate on the project. The name of the project is a learnable and edge cloud cooperative network for driving emotion sensing. The content includes the following four parts. Part 1, Innovation Background and Introduction. Part 2, System Architecture. Part 3, Key Technology. And Part 4, Research Results. First, let me introduce the Part 1, Innovation Background and Introduction. According to statistics, road traffic accidents cause about 1.3 million deaths and 20 million to 50 million non-fatal injuries in the world every year. About 94% of traffic accidents are caused by drivers' cognitive errors, decision-making errors, operational errors, and non-operational errors, such as drowsiness. Emotion is an important factor that affects the driver's cognitive level and decision-making status. Negative emotions, such as road rage, will lead to the decline of the driver's decision-making ability, leading to decision-making mistakes and serious traffic accidents. About system introduction. Intelligent Emotional Perception Safety Assistant Driving System monitors the driver's emotional state in real time. The Intelligent Vehicle Safety Driving Assistance System integrates edge computing technology, adopts an edge cloud collaborative emotion perception network model effectively, improves the regulation accuracy and processing efficiency of driver emotions in single vehicle and multi-vehicle scenarios, and reduces the amount of network transmission debt and system resource consumption through a series of optimization processing on the video stream that perceived by the camera in the vehicle. The negative emotion of the driver can be accurately obtained, and the effective active safety control strategy can be developed. Advantages of system innovation. First, the end-to-end cloud-cloud collaborative processing mode can significantly reduce the transmission load, thus ensuring the low latency requirements of perceptual information processing. The combination of deep learning and edge computing can significantly improve the stability of the Internet of Vehicles system. Lightweight emotional perception model optimization design, dynamic update of emotional perception model, improve the accuracy of emotional regulation. Part 2, System Architecture. So let's have a problem analysis. With the improvement of camera resolution, the video data generated by the camera per second increases sharply. The parallel video data of multiple vehicles causes the bottleneck of uplink transmission. The high-speed movement of vehicles will lead to dynamic changes in the wireless link channel environment. Video data processing brings huge computing and storage requirements to the vehicle emotion regulation terminal. The traditional centralized processing mode results in excessive load on the backbone network and large response delay. which is difficult to meet the real-time requirements of the intelligent vehicle network. System architecture. The onboard terminal obtains the driver's facial information and carries out periodic facial video acquisition, keyframe extraction of video stream, image compression coding, and data transmission. The edge server receives the images collected by the terminal regularizes. The image coding data integrates the emotion regulation model into the ROI feature extraction and carries out regulation analysis on the face features. The cloud receives the abnormal face ROI image that's regularized by the edge server, trains online, and publishes the optimized emotion parameter perception learning model to the edge server to ensure that the edge server dynamically adjusts the working parameters of the emotion perception learning model. Part 3. Key Technology. Key technology is about human-computer interaction framework of emotion perception, keyframe extraction and compression coding technology, optimization design of net-weight emotional perception model. About human-computer interaction framework of emotion perception. The emotion regulation framework based on end-to-end human-machine cooperation is divided into two parts: face perception in the car and edge regulation. The former is composed of periodic face video acquisition, image key frame extraction, compression coding, and data reporting by the car camera. The latter receives the image encoded data, uses the emotion regulation model fused with ROI to conduct online training of expression features, and improves the regulation efficiency of features through the deep separable convolution neural network. Keyframe extraction and compression coding technology. The system adopts a keyframe extraction method based on interframe difference. This method converts the true color image into a gray image, differentiates the corresponding pictures of different frames, selects the keyframe using the local maximum value, and filters out most of the redundant frames. Compared with the deep learning algorithm, the interframe difference algorithm tasks less resources, consumes less time, and has less precision attenuation. Compression coding. An improved Huffman image compression algorithm based on heap-sorting Huffman. This algorithm improves the speed of image compression on the basis of ensuring lossless compression. Optimization design of lightweight emotional perception model. The Edge service platform deploys a lightweight emotional perception model based on ROI feature extraction, which senses the driver's emotional state based on key frames and makes timely feedback. The cloud receives the abnormal face ROI image data regularized by the edge server and trains the tiny X concept model online. Steps for extracting the region of interest of the driver's face image. First, locate the key feature points of the left eye, left eyebrow, right eye, right eyebrow, and mouth in the face image. and obtain the coordinates of the region of interest, the vertical coordinates of the upper and lower ends, and the horizontal coordinates of the left and right ends. Use OpenCV to split the left and right areas horizontally, and split the part and the mouse area vertically. Perform image enhancement and other processing to obtain high-quality feature images. The tiny exception network is based on the exception network and combined with the deep separable convolution to delete the fully collected layer, which reduces the number of parameters and the amount of computation and plays a role in the compression of the exception network. The tiny exception network contains 4 deeply separable convolution models. Each convolution layer uses batch normalization and real LU, corrected linear units, activation function. The next layer uses the global average pooling layer and the softmax layer to generate predictions, which can prevent the network from overfitting and reduce the network size. Part 4. Research Results. So now let's talk about research results. Under the Welcome Human Road Cloud Integrated Control Framework, we propose an end-edge cloud collaborative emotion perception network model. The end side extracts the keyframes of the driver's face video stream and performs batch compression. The edge side extracts the region of interest of the reconstructed images as the input of the emotion regulation model for classification. The cloud control terminal receives abnormal ROI image data and performs online training to dynamically adjust the operating parameters of the edge model. Finally, we test on open and self-built datasets, and the results show tiny exception has a significant improvement in accuracy of 2.45% compared to many exception. The EECNet model can reliably perceive the negative emotion period, and the overall system memory consumption is reduced by about 5%, and the network transmission data volume and the computation time of emotion regulation are reduced by 95%, 60% respectively. And that's all. Thank you for listening.